got from a Mitsubishi perspective in this little panel is the D700 drive and the Mitsubishi MERTU with the FX5.
Alright, Dave, the inlet to the plant comes from the well or the river. That's the inlet. The water is filtered through the membranes. It's then monitored by these two flow meters. It's distributed to the tanks by the distribution pump. We also have a blower here that will backwash the membranes periodically. And down here we have a dosing pump that doses chlorine into the water to sanitize it.
And typically, what is your installed power to run this unit, and what is the operating parameters of this particular unit?
Okay. On this plant here we have 5 kilowatts of installed PV panels. That produces about 4 kilowatts of useful power where we are here. And the plant is configured with a valve here to simulate a 30-meter head from the well. And we're producing about 60,000 litres of water a day. And it's pumping for about 8 hours of the day.
That's quite significant in terms of being able to take rough water, whether it's a borehole or a river,
yes,
with a fairly amount of solids in it, I guess, and be able to filter it down to potable water.
Yes.
Interesting.
All right. And Dave, also this plant sits on top of a soakaway here, so the discharge from when we backwash the membranes just runs into that, and it filters its way back into the ground again.
So completely healthy from a point of view, environmentally safe.
Yes.
And in fact, we are solving a major problem here by delivering potable water out of some pretty raw source.
Yes.
Interesting. Thank you. Thank you very much. Obviously, the challenges were that the PV solution is not an absolutely stable power source. So we had to take care of dropping DC voltage very quickly and still not tripping the drive.
Correct, yes. Those were taken in control in terms of the upper and lower limits that we set, and the drive then be able to bring it into just a state of rest instead of in a trip state, yes.